Hello everybody. We're gonna go through the answers to this one. So this problem, or this page, you'll see a whole bunch of multiplication expressions, and I think a couple of addition and subtraction ones. And then you're trying to match the answers here to the answers in the box below. And then you'll kind of get the answer, the riddle answer. So it says solve all the problems in both sets of boxes. Each answer in the top boxes matches the answer in the bottom boxes. Discover the answer to the question above by writing each word from the top set of boxes in the box below with the matching answer. So if we get 26 up here, we put the word if in the place, oh sorry, not 26, 246, then we put the word if where we have 246 down here. One example has been done for you, right? That's that one. So before I go trying to solve all of these, I'm going to see if there's some that match with what I know about multiplication expressions being equivalent. So for example, if I have 12 times 4, hopefully you all know right away, that's 48. But I know an equivalent expression would be doubling and halving. So if I say times 2 and I make 12 24, and I have, if I cut in half, divided by 2, the 4, that's 24 times 2, that's also 48. So this is doubling and halving. We talked about it in the beginning of the year. And there's a bunch of problems on this page that follow that, that type of a model. Some of them are doubling and halving. Some of them are like multiplying by 3, dividing by 3 to each of the factors. So let's look for a few of those first and see if we can find any of those. So right away I'm noticing 10 here and 5 over here. So let's take a look at 29 times 10 and see if it might match 58 times 5. Notice I have a scrap piece of paper. Don't be doing all of this stuff on the page. I don't think you have enough space to do all the work you need for this page. So I know that 10 divided by 2 is 5. That part I totally know. Now my question is 29 times 2, is that 58? So I'll just maybe you can do that in your head. I'll double it just by adding. 9 plus 9 is 18. 2, 4, 5, 58. Yes. So this is a doubling halving question. So without even solving that problem, I know that the 58 times 5 is equivalent to the, where did I find it? 29 times 10. So I'm not gonna write in the words here because you gotta do that part. And then I'll cross this one off, right? Because then I'm done with it and I know I won't have to look at it again. Same thing with this one. Okay, let's see if there's others that kind of stick out as being a doubling and halving type relationship or something else that could be useful like that. So 44 times 6, 74 times 3. Well, 5 times 9 is 45. This one's a fact that I just know off the top of my head, and 12 times 4 is 48. So maybe we can find a couple that would match easily for that. It takes a little bit of time to try to see if you can find some of these. They don't necessarily just totally jump out at you, but I'm just saying if you spend a little bit of time trying to find the ones that match, then you might save yourself some time in the end. Oh, look what I just saw. Here's 11 times 9. Here's 22 times 8. So that one kind of just, oh, no, that's not going to work, right? I thought I had it because I had a double here times 2, but 9 divided by 2 is not 8. So this one doesn't work. And that's okay. When we are trying to find these relationships, sometimes the one that you think you have is going to be right, and sometimes it's not, and either way is all right. This one I know is 210, so I can keep a lookout for something that's 210 as I go. And then I know that 12 times 12 is 144. So, you know, I'm seeing some things that maybe that I might be able to realize later are going to work. Let's try to I'll try to find one more for us, and then the rest I'm going to have you do on your own. So right now what I'm doing is I'm thinking, okay, I'm seeing a lot of like 3s and 6s, and I wonder if there's something here that I could use for doubling and halving with 3s and 6s. So we have 33 times 3. That would be, let's see, oh no, that one wouldn't work, because if I double 3, that's 6, but if I cut 33 in half, then that's 16 and a half. So we're not going to have any mixed numbers here. This one's 420. As I go and I find ones that are easy to solve, I'll just fill them in, because that makes life kind of easier for me. Maybe pause and see if you can find a couple that match. Oops, 48 times 1. So that one matches. So you'll notice this one is 48 and this one's also 48. This one is mental math. You don't really need to do anything, but it does still follow our pattern. 48 times 1. If I divide 48 by 4, I get 12, which means I would have to multiply my 1 times 4, and I would get 4. So these are an equivalent expressions again. Okay, so take a look and see if you can find other equivalent expressions. If not, some of them are not. They don't follow this pattern. They don't match through equivalent expressions, and so in that case, you're just going to have to solve some of them. So there may be some that you end up having to just go ahead and solve out using whatever strategy you want. Remember, we have the area model, which looks like this, where I would say, let's say, for example, 24 times 9 would be something like 24 times 9, and I would do 9 rows, each with 20, is 180. 9 groups of 4, 9 rows of 4 is 36. Add those two together, 216. And then you'd look for 216 in here. Try to go ahead and finish this off. If you have any questions or you're struggling and there's some that you're not getting, then definitely message me as always. Thanks, guys.